My name is Yao Wang from the University of Stuttgart. On behalf of my co-authors, I am excited to present our work, SalChartQA, Question-Driven Saliency on Information Visualizations. Information needs is a term first introduced to describe how a user obtains answers from an information system. Another good explanation of information needs is the difference between what you know and what you need to know to complete a task. This term applies to the process of observing information visualizations perfectly. Users usually first freely explore an infovis, then raise some questions to themselves, and finally find the answer in the infovis. In this work, our scope is to study the question-driven oriented observation, also known as the question-driven saliency. For example, users might first have seen the blue bars and wonder what does blue bar represent. Then, they will check the label above the blue bars to find the answer, developing alternative energy. Tasks or questions given to users are an explicit form of information needs. Previous works have learned that users' attention could be completely different given different questions. For example, their attention focused on the labels of blue bars if the question is to calculate the average value of blue bars, and focus on the shortest green bar if the question is to find the lowest value among the green bars. To understand how users' information needs influence visual saliency, we introduce questions as a middleware to control the information needs. Then, question-driven human visual attention could be well studied. Our work is threefold. First, we propose SalChartQA, a novel large-scale human attention dataset consisting of more than 74,000 answers to 6,000 questions on 3,000 information visualizations. Our study was based on the ChartQA dataset. ChartQA covers three commonly used visualization types: bar plots, line plots, and pie charts. It also has two high-quality human annotated questions per visualization. We randomly selected the 3,000 visualizations which corresponded to 6,000 questions from ChartQA. With the bubble wheel method, each visualization was blurred, and participants were asked to answer the question by clicking on the visualization, thereby unblurring small parts of the image with each mouse click. Once they find the answer, they type the answer in the response field and proceed to the next question. We split every 20 questions as a human intelligence task on Amazon Mechanical Turk and received about 4,700 responses, where the answer accuracy of participants are depicted in the bar plot. To ensure the data quality, we discarded the responses with an accuracy lower than 40%. We then generated the 6,000 question-driven saliency maps from the filtered data by applying Gaussian kernel to all mouse clicks with a sigma of 1 visual angle. Then, we performed several analyses on the collected data to see the influence of questions on human visual attention. Shannon entropy quantifies how much a saliency map differs from a uniform distribution by a positive value ranging from 0 to infinity, while saliency coverage quantifies how many pixels are activated given a certain threshold on a grayscale map. Comparing Shannon entropy and saliency coverage between easy questions and hard questions, we find that hard questions have significantly higher Shannon entropy and saliency coverage. It indicates that people spent more effort seeking for answers for hard questions. Given the evidences above, we seek to predict question-driven saliency on information visualizations. We propose with-SAL-Former. With-SAL-Former takes a question and a visualization as input, and yields a question-driven saliency map. We first obtain visualization and question embeddings using pre-trained swing and BERT transformers. Then, we propose a cross-modality feature fusion module to handle multimodal inputs consisting of a visualization and corresponding question. Finally, a CNN-based decoder uses the fused latent features to generate a saliency map. We then evaluate the proposed vista former with baseline saliency models on SalChartQA. Our vista former dominates the best baseline, which is the trend-cell net, where all 5 saliency metrics are significantly higher. We also qualitatively evaluated the performance of vista former with the strongest baseline trend-cell net. The saliency maps from trend-cell net is depicted in the middle row, and since there's no question input for trend-cell net, it yields exactly the same saliency maps no matter how questions changes. On the contrary, our method depicts question-specific saliency maps that are more closely to resemble the human ground truth. In conclusion, this work proposes SalChartQA, a novel large-scale question-driven saliency dataset, and makes use of this dataset to train vista former, the first computational method to predict the question-driven saliency on InfoVis. Our work informs the future development of new applications that are able to take users' information needs into account, such as in design optimization and explainable AI in chart question answering. Thank you so much for your attention.